Hi guys, the sorting method chosen by our group is the insertion method. For this video, I'm gonna talk about some brief introduction of the insertion sort and with an example to explain this sorting method. It's really easy to understanding, I promise. And after that, I'm gonna talk about some properties of the method like the running time analysis or if the insertion sorting is stable or not. Okay, my name is Ao Ding and my team partner are Hongbo Wang, Zhongyi Jiang, and Abo Lei. Let's go to the next part. Okay, let's go to the first part of our video, which is a brief introduction about the insertion sort. The insertion sort is a sorting algorithm that places an unsorted element at its suitable place in each iteration. The insertion sort works similarly as we sort card in our hand in a card game. Like we assume that the first card is already sorted, then we selected the second one as an unsorted card. If the unsorted card is greater than the card in hand, it's placed on the right, otherwise to the left. In the same way, other unsorted cards are taken and put in their right place. It's a similar approach is used by insertion sort. And I insert a GIF graph in the presentation, and it is really show how's the insertion sort working clearly. So let's take a look at this picture as an example. We start with the second element 3 in row 2 and compare it with its previous element, and put 3 before the minimum element among the elements larger than 3. So we put 3 before 4, and we do the same process about value 2. And then as you can see in the row 4 and row 5, value 10 and value 12 have already been larger than all their previous values. So we just let them stay in their original places. For the value 1, we just follow what we did before to put it on the hand. And for value 5, since it's smaller than 10 and larger than 4, so what we need to do is to put it between those two numbers, and so that's value 6. And then we're going to talk about the running time analysis for the insertion sort. The best case for the insertion sort is when we have an already sorted array. Then each key we only need to compare with the previous one. So the time assuming of that is just O of n. Then the worst case we might face is when we have an array but sorted by descending order. Then we have to use each key to compare with every element and its approach to the head of array, which gonna be take like O of n squared. Okay, the next part is about the insertion sorting is stable and in place or not. Of course, the insertion sorting is a stable sorting. We can observe it, the image I show at the left. Stable sorting simply means the relative order of the duplicate elements should not change. In the insertion sorting, we just pick an element and place it in the correct place. And in the logic, we can only swap in the elements if the element is larger than the key. For example, we are not swapping the element with the key when it holds the equal condition. So it's a stable sorting. And the insertion sorting is an in-place sorting algorithm that builds the final sorted list one item at a time. It works on the principle of moving an element to its correct position in a sorted array. Okay, we're going to talk about something cool about the insertion sort at the end of our video. Insertion sort can be used when only part of arrays are received. The insertion sort considers one input element per iteration and produces a partial solution without considering future elements. Thus, The insertion sort is an online algorithm. Well, I have come to the end of my presentation. Hope you guys learned something after watching our video. Thanks for the listening and watching. Have a good day.